Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is an X670E, a very decent board with decent I/O. It still has the original protective foil or whatever this is, and it is here for socket replacement. Now we're gonna take a look at the socket, and I already see that there's stuff around it, so it's not gonna be easy in a way where we can use a protective foil that just is easier to use than, combination of Captain tape and aluminum tape. But probably we don't even need to protect anything here. Ooh, the socket looks not great. There. There are screws on top over here. I don't know if we need to remove that or if I just remove the heatsink from the bottom, this will come off. Weird. I haven't seen the design like this yet. Oh, looks like it's connected to this over here. Yeah, that's weird. So the screws are also on the top over here, but it looks like it just holds this little plastic here. And it's a long one. Let's see, is it 2 PCHs? Yeah, 2 PCH chips. That's why it's so long. We have 3 PCI Express, and yeah, 1 full, half, and quarter. Very nice. Plenty of SATA connectors. This can stay on, but we need to remove the V-core. So the top one's always easier. Looks like it's gonna be a single piece, which sucks because then reassembly is a pain. Looks like 4 screws on V-core plus 2 screws over there, so 6 screws on V-core. Typically it's 4. Oh, luckily it is separate. So thermal pads look good. I will probably have to get some replacement pads because on some boards, when I remove the heatsink, the thermal pad looks awful. Yay! Okay, I love this design, so I don't have to. Oh, that's why it was 4 screws. So there's 2 on the heatsink, and there's additional little heatsink underneath. I've never seen that before. Typically it's a single piece of aluminum, but here we have 2 of them, and that's probably a USB chip, or no, this is probably PMIC for V-core. But no, PMIC doesn't really require heat sinks, right? Because it controls the output stages. The output stages heat up, not the control chip. So I don't know. Okay, this can stay. It's no problem. It doesn't get that hot, although it is plastic. Let's see. Yeah, quite a few screws to remove it. But then this, typically I just leave this be. Never melted on me. Well, unless you move the top heater and you move it over here when it's too hot, then yeah, it will melt. Sure. Alrighty, so the board is prepped. Oh, let's see the socket. This is not bad. This could have been corrected. Alright, so minor issues at the bottom over there. This is more serious, but I don't see any pins missing. Oh no, maybe there is one missing. Oh yeah. Oh yeah. Yeah, it looks like someone did try to correct this. Let's see. Oh no, maybe not. Ah, this one's here. Alright, so this one could have been probably corrected. Let's see this one. Yeah, it's pretty mangled here, but it looks like all the pins are there. Yeah, this one's here too. Yeah, this could have been. Yeah, you could probably revive this one. Those modern pins that they make now, they are a lot more resilient, as they are, as you can see, the two. It's not a single pin. There's like two plies to it. All right. So that makes it less prone to actually breaking, right? And easier to bend. Yeah, those new sockets, they are much easier to correct. The LGA like 1200, 1151, those Intel sockets, they are difficult to correct. But this one, look how easy it is, because you can grab it in the middle like this, right? And just push it in the right direction. There, fixed. So yeah, this could be fixed without the replacement. But the board is here for the replacement, and you know, as far as the success rate on the boards with bent pins, it's always actually the same with the socket replacement, because the replacement also doesn't really give you any guarantees, because the board itself might get damaged due to heat. But with the bending pins and stuff, it, you know, you gotta look at it from many different angles, and it's never gonna look the same. It's never gonna look like new. So there's no way to RMA it after that, and it can cause subtle issues, because the board will turn on, it will post, it'll boot to system, but then you start either playing a game or working on video editing or 3D modeling or something like that, and there are subtle issues. Either the computer freezes, or it just takes too long, or that kind of stuff. And when that happens, you're never sure whether it's actually because of the bent pins and stuff, because there's no way to see how the pins are bending once you put the CPU on, right? So that's the main issue. So yeah, I usually just go with the replacement. Alrighty, let's get to it. Let's speed up the footage, because it's gonna be so boring, and let's see, probably let's do 45 minutes maybe of drying and preheating. So I'm gonna probably preheat it on the, say, maybe 100 degrees, 120 degrees for like 20 minutes, and then another 20-25 minutes for the actual preheating to 210. And now, new version of Rework Pro has been released. There are just few minor features, but efficiency has been greatly improved. A few bug fixes, and new feature where you can, when you hit preheat, long preheat, there's a checkbox you can hit to start the profile after the preheating is done. I hope that's to your liking. If you have any suggestions on what features to add, definitely either email me, hit me up on Discord. You can even throw the suggestion in the comment. I'm always happy to deliver the features that were actually requested by the users. That's like gold to me, as far as feedback goes. If you use the application and you would want some feature that will serve you or save you time or make you more efficient, that I love delivering that, because happy customer is always the best thing, and the software becomes more valuable, so everybody wins. All right, let's get to it. And we are done. This is pretty much as textbook as it gets. No issues. Alignment seems okay. And it cleaned nicely. There's a little bit of discoloration inside, but you wouldn't even tell if you didn't know. It let loose at 195 because I forgot to switch it to 205. Normally I load that preset, the the AM5 socket or whatever, the first one on the list, and but I always switch it to 205, the maximum temperature, because it is set to 195, and I always switch it to 205, and I forgot, but it let loose. No problems there. I think it was this way. Yeah, on that chip, not this one. Yeah, reassembly is always a hassle. I mean, not. It kind of depends on the board. This one's actually very non-problematic board. You know, the most problematic boards are the ones that have the back plate, the whole big plate on the back, and you really have to remember the order in which the screws came off. On these, the order is not that important because everything can be assembled, almost everything can be assembled in whatever order you want, right? So this is a lot easier. And I was thinking probably even that little heatsink that I'm putting on right now, we probably didn't even need to remove it. And as you can see, I didn't put any protection on the memory or anything. No damage, no discoloration, no deformation, nothing like that. Usually it's the matter of preheating. If you preheat it well, you don't have to protect that much because you're operating with minimum temperature because the board is properly preheated. That's why Rework Pro is so effective for this work, just for that very reason, because you can do good preheating cycle. So what I did was first around 100 degrees at the bottom, right there. Come on. Then about 120, 160, and so on. So the total preheating was roughly half an hour. You should be able to see that in the footage, which means you don't have to use 205 at the top. But it always depends on the board. Some boards I treat with, even with good preheating, I treat with 195 at the top, 210 at the bottom, and you know, the socket is just sitting really well. Some boards are thicker, some boards are thinner, so there's no universal profile for all of them. You just have to, you know, once you start heating it up, trying to remove it, once you start doing that, then you see you have to adjust, basically. If it's not letting loose, increase it a little bit. But always work from the lower temperature to higher temperature. Don't default to higher temperature, because you can always increase it. But once the board bubbles up, and we've seen that on one of my repairs. Luckily, that was the board that the customer didn't really care for too much. I mean, if it works, it works. If it doesn't, just keep it for parts, right? But the board bubbled, which was too bad. But yeah, that was pretty much my fault, because I wouldn't have fried it nowadays if I had to do it nowadays. I was still getting putting a handle on this procedure, and I think I just used temperature that was too high, and that was the whole issue. But also that was a specialized board pretty much, so it was not unlike anything else I worked on, and it was like some kind of weird socket. I don't remember which socket it was, but it was a weird socket, very big one too. So at the very limits of of my abilities. But AM5, I've done so many of these that it really doesn't scare me. And you know, as long as the socket is aligned and all four corners are solid, you know, I call it fixed. But we don't know. The customer will know once they actually test it, because a lot of stuff can happen, meaning the board flexes during that procedure, although it flexes very minimum flexing when you do proper preheating, meaning long preheating, right? It flexes the minimum amount, but it still will flex. There's nothing we can do about that. It's just, you know, the copper's heating up, and it's not gonna deform uniformly. So some tiny traces could break inside. So there's always some risk attached to it. And the socket, or the bracket, the CPU bracket, in there, and here, and here, and the last one, last piece. Okay, now we just need to keep it in a dry place for a little bit. I don't want to send it in this because I can feel the moisture, especially when you move across the memory. Let me show you. Right, you move your fingers here and you see the moisture inside, right, from the ultrasonic cleaner. All right, I do treat it with a hair dryer, so I do dry it, but you know, there's no way to dry it, you know, just using few minutes with the hair dryer. It needs to dry naturally. This is primarily an isopropyl alcohol and some alkaline and distilled water, right, for cleaning. So it's definitely not good if you turn it on while it is wet. That's why I prefer to keep it and let it dry in my shop than rely on, you know, making or rely on the customer doing the due diligence of drying it, right? Because it's not your job as a customer to dry it. You should receive it, in my view, you should receive it in the form where it's ready to be used, right? So that's what I want to do. So probably this will go out on Monday. Alrighty, let's move on to the next repair, and this one is done. Thank you very much for your business. Thank you very much for watching. I do appreciate you, and I shall see you guys in the next one.